Even and odd functions. You can tell if you have an even function if it has y-axis symmetry. So this is an example of an even function. So a function whose graph has a y-axis symmetry is an even function. Y-axis symmetry means that if you take this portion of the graph here and you fold it over the y-axis, it lands on itself. Notice the y-axis cuts the graph into two equal parts. Y-axis symmetry. So if xy is on the graph, so let's say 3, 5, that would be 3, 5. Negative 3, 5 is also on the graph. Negative 3, 5. Okay? Origin symmetry. Remember, the origin is this point right here. To have origin symmetry, if you take this portion of the graph here and you reflect it over the y-axis, so it'd be over here, and then you flip it or reflect it over the x-axis, it lands on itself. So this is an example of a cube root function. This is a cube root function here. So this is an example of an odd function. So if it has origin symmetry, if you can reflect it over the y and over the x, and it lands on the other portion of the graph, then you have an odd function. So if xy is on the graph, so say 8, 2, then negative 8, negative 2 is also on the graph. Negative 8, negative 2. Okay, x-axis symmetry. Well, notice right off the bat, we do not have a function. But this portion here is reflected over the x-axis and lands right here. So if you have this symmetry, okay, it's neither even or odd. So you would write down neither. But if you do have x-axis symmetry, if you take a point, say 9, 3, 9, negative 3 is also on the graph. Most important thing to keep in mind here on this page, you need to know that if it has y-axis symmetry, it's an even function. And if you have an origin symmetry, then you have an odd function. Everything else would be neither even or odd. Okay, turn the page. A function is an even function if f of x is equal to f of negative x. We'll take a look at this a little closer later. A function is an odd function if f of negative x is equal to negative f of x. Does that seem confusing? Well, we'll be clarifying this more in the near future. Okay? So first of all, let's go down here. We'll come back to the tables in a moment. But we want to determine algebraically if each function is even, odd, or neither. So we're determining it algebraically. So we have a function. It's a cubic function, and it's been translated 4 units down. The first thing you want to do is you want to find the negative of that function. Okay? So what does that mean? When you find the negative of the function, that means we're multiplying the function times negative 1. So we're taking negative 1 times this function. Okay? So what does that give us? That gives us negative x cubed plus 4. Okay? Now, what we want to do next is we want to input a negative x into the function. Okay? So we're going to input negative x into function f. So here's function f. So everywhere we see an x, we're going to plug in a negative x. Now we need to simplify. And so what we have here is we have a negative 1 raised to the third power. Well, negative 1 raised to the third power is negative 1 times negative 1 times negative 1. And that's going to equal negative 1. So negative 1 to the third power is negative 1. And then x to the third power is x cubed minus 4. Now what we want to do next is we want to compare this function to the original. Are they the same? No. Okay? So here it is. This is what we just did. We substituted negative x into function f, and we're comparing it to the original function to see if they're equal. If they were equal, we'd have an even function. Notice that this function is not equal to the original function. Okay? Next thing we want to do is we want to compare the function we just got to this function, negative f of x. So we're going to compare this function here to this one. Are they the same? No. So if they were equal, then it would be an odd function. So we write neither. Next one. Okay, so first thing we want to do is we want to multiply the function times negative 1. And so we're going to have negative 1 times the absolute value of x. So we're going to have negative absolute value of x. Just like that. Don't put the negative on the inside, just put it on the outside. Okay? Remember, that's always the first step. We want to know what the original function equals, and we want to know what the negative of the function equals. Now, we do the f of negative x, and we plug it in to the original function. So notice I plug negative x in for x, and this is what I get. Now remember, absolute value of a number is always positive. It's the distance the number is from 0. So remember, this is a negative 1. And the absolute value of negative 1 is positive 1. So we get a positive 1x. Okay, now we do the comparison. So does this equal the original function? Yes. So that means that f of negative x is equal to f of x. Okay? And compare that to this. F of negative x is equal to the original function, so it's even. Even. Okay, moving forward. First thing we do, again, we did it once, we did it twice, third time. Multiply the function by negative 1. Okay, so we're going to have -1 times f of x, distribute, so we get x cubed minus x. Okay, next step, we did it here, we did it here, we do it again here. We plug -x into function f. Okay, so we're going to have, now this is where you got to be careful. So negative, then we plug -x in, cubed, plus, and then we plug -x in, and then we simplify. So a -1 to the third power is -1. -1 times -1 is +1. Make sure you cube that -1 before you multiply by -1. Order of operations. And then minus, because a positive times a negative is a negative, minus x. Okay, so does this match the original? No. So it's not even. Does this match the negative? Yes. It matches the negative. They're equal. So it is odd. And so that's how algebraically you determine if you have an even or odd function. Okay? And we'll talk about the tables in class. Right now I wanted to cover those two things, that you know how to determine even or odd using symmetry, y-axis symmetry, even, origin symmetry, odd, and then algebraically. Hope you're having a great weekend, and I'll see you on Tuesday.